Welcome to this video. In this video, we are going to solve KodeCloud's CKS lab challenge number 4. Let's look at the problem statement. It says that there are a number of Kubernetes objects created inside these three namespaces, Omega, Citadel, and Eden Prime. However, some of them are having suspicious activities happening in those namespaces. So to identify those suspicious things, we need to enable auditing in the API server as well as the Falco auditing, generate the reports, and then fix those anomalies. For example, they have given this applications link. And after 30 seconds, if we see this, the color of this application will change. We will click here, we'll refresh this page in another 30 seconds to show that this application is changing suspiciously. In the meanwhile, let's click around the problem statement and see what various asks from this question are. So if I look at the audit log icon, it says that audit log path should be set at this location. Auditing says that audit policy should be at this location, and then we need to mount it as a volume into API server, something we have done as part of lab 3 as well. And then we need to create an audit policy this time. In lab 3, we only enabled auditing. This time we have to enable auditing as well as create an audit policy. And it says create a single rule in the audit policy that will record events for two objects depicting an abnormal behavior in the Citadel namespace. So for two objects, it's not specified here. This rule should, however, be applied to all three namespaces shown in the diagram. All right, so maybe let's look around the Citadel namespace if we can find out what's anomalous here. If you look at pod, delete the role causing constant deletion and creation of config maps and pods in the namespace. So this reveals the two resources, config maps and pods. So the auditing policy that we need to create needs to be around config maps and pods. All right, let's quickly click on the other icons to see what the asks are. For Falco, it is asking to install the Falco utility from scratch. And then it talks about generating the Falco logs at this particular file location. And then it is asking about reading the audit logs as well as the Falco logs to identify which user role binding are responsible for certain suspicious events in both the logs and store that information in respective files. If we look at the namespaces, Eden 1 says that in the security report that you have generated, the compromised pods that you have identified from the logs, we need to delete those pods without touching the non-compromised ones. Citadel we saw earlier as well. There are issues with config maps and pods. So we need to delete those role bindings which are causing constant deletion of these config maps and pods in this namespace. And in the Omega namespace, the last part is delete the pods that were flagged in this particular security report. All right, so we definitely need to enable the audit logging in the API server first, and that acts as an input to Falco. So we need to install Falco and ensure that the output of Falco logging is getting generated in this particular log file. Going back to the Citadel web app, previously when we opened, it was with a blue background. Now if we refresh it, see the background has changed. So something suspicious is happening in this namespace, which has modified our deployed application, which is not a desired behavior. So we need to identify those vulnerabilities and fix them. So let's start the lab solution. Let's launch two terminals and let's quickly set up aliases. All right, let's click on the audit log. Let's see if this path actually exists. If not, then we'll create it first. Okay. In lab 3 also we saw that when we were putting an audit log file into our API server with this path not being existent on the host machine, our API server crashed. So here proactively we are ensuring that this path exists. All right. Let's click on the auditing. So we need to create this audit policy which talks about changes in the config map and ports as we saw in the Citadel namespace. However, this policy needs to be applicable to all three namespaces, and we need to log at metadata level. This is another important piece of information. In the policy, we need to give the level, which can be none, metadata, request, or request response. So here we need to give metadata, and we need to omit the request received stage. All right, so let's start creating this file. Now, to create this file, let's quickly look at the Kubernetes documentation. Let's click on auditing link. Let's go down. So this is how an audit policy looks like. Maybe let's just copy one of them. And if you see, the groups is blank for pod resource as well as for config maps. So we can basically use the same group for both. So let's just copy this part maybe and then start creating our YAML. We need to create this policy at this location. So let's do that. Okay. The question does talk about omitting the request received stage, which is fine. The logging should be at metadata level. So let's change that. So we can update what resources we need this audit policy for. Pod is already there. Let's add config maps as well. And then we need to give namespaces. The way to do that would be given in one of the examples. There you go, namespaces colon. And we need to do this for all the three namespaces. So let's just give all the namespaces. Omega, Citadel, Eden Prime. All right, this looks complete now. Let's come out of it and let's try and update our API server with this audit policy and the audit log location. Let's provide the audit log policy and the audit log paths location as a property. You can actually find them here as well. So let's copy from here. And just to verify, these paths are exactly what we have configured as per the given question. So policy file at etc kubernetes audit policy.yaml and log path is var log kubernetes audit.log. Just to double check that, click on the audit log. There you go, var log kubernetes audit.log and auditing policy at etc kubernetes audit policy.yaml. Next step, very important, these paths should be mounted as volume. So let's do that part. Let's create two host paths for this. The first one, let's call it audit log of type host path. Which is further of type directory or create. And the path is var log Kubernetes audit. Similarly, let's create the other one. This time it's a host path of type file pointing to the audit policy YAML. Yeah, name audit, host path this. Now let's quickly add the volume mounts. Name is audit log and mount path. You can simply take it from the volume section. This is where your logs will be generated. So no need to add read only true here because it's a write operation, writing logs to this path. However, the next volume mount where we supply the audit policy file, that you should be marking as read only true. That policy file should not be changed by API server. So the name of this volume that we have created is audit, and mount path is this entire location till the file name. And as we spoke about, let's make it read only true. All right, looks okay. Let's just try to save the Kube API server and let's just wait till the API server comes back up just to make sure that we have not broken anything. So yeah, the cluster is back up. So API servers is all healthy. You can also check that going into kube system namespace. Yes, everything is healthy. Maybe let's go back to the lab and hit the check button just to see if we have correctly solved our first part of this problem. Something doesn't look right about the audit policy. Maybe let's double check that. Policy looks all good to me. I don't think there's anything wrong here. Not sure why lab is still showing the auditing icon in red. We'll proceed to the other parts of the problem and then see whether this becomes green or not, but I don't see anything wrong in the policy and looks all good to me. Let's proceed with the next step of the problem. Let's come out of it. And the next step is talking about Falco installation. So in the exam, you will be provided link to Falco documentation. So you can go to the install part of this documentation and follow the installation instructions. But I would assume that in the real exam, Falco would already be installed and you won't really be asked to do all the steps manually and set up Falco. So I won't go through all the steps one by one. I'll just configure Falco right away. Let me just run the commands that I have copied over in my text pad. Hmm. Let's just see, is Falco running? So right now it's inactive. So we can go ahead and start Falco, but before that, let's see if we need to make any change. We actually do. The log output section of the question says that the Falco should be saving the events to the OPT Falco log directory. So there's something we need to update in the Falco configuration. So the path for that is etc falco slash falco.yaml. Again, a path that you need to learn by heart for the exam. Actually, this is a file, so we'll directly do a VIM. Looks like we have done something wrong here. Maybe let's just look at the installation steps if we are missing anything. Actually, there's a typo in our command, so let's correct that. etc falco.yaml. This should be fine. Yeah, that is the Falco configuration. So these are the rule files that it is checking. As per the question, we are not supposed to write any new rule or make any change to the existing rules. So that's fine. Let's skip this section. Let's come down. We will have something of file output. This is the one, file output. Right now it's disabled. So let's enable this. Enabled colon true and the file name where we want to save the log. So as per questions, the path is /opt/falco.log. OPT, not PT. Great. Let's now start Falco. Let's check the status. We can see that Falco is up and running now. Let's go back, hit the check button. Great. So we can see that Falco section is green and the log output is also green. Now let's move to the next section, the security report. It says inspect the API server log audit logs to identify the user responsible for the abnormal behavior in the Citadel namespace. Save the name of the user, role, and role binding responsible for the event to the file at this location. Everything should be comma separated. So let's look at the audit log file. The way you go about checking the audit log file would be you open the audit log first. So these are all the events. Let's filter them out based on the name of the namespace. Now we have only Citadel events. There are too many events, so you can opt to look at only the top 4 events. The command for that is head -4. You have now 4 events. And if you want to further beautify these results, just so that you are able to look at the events in a more friendlier representation, you can use JQ utility. So now you can see the events that we are searching for are pretty clear, and we can see who is performing the events. RBAC allowed by role binding. This is the role binding. This is the role, and this is the user. All right. So we have found the name, the role, and the role binding. Let's put all of these into the file location as given in the question. All right. Let's check the file quickly, just to ensure that things look fine. Yes, all 3 values comma separated. Great. Now let's move to the second half of the problem. Inspect the Falco logs and identify the pod that has events generated because of packages being updated on it. So we saw the Citadel web app that is changing in the background. So some packages are getting updated. We are going to identify those events in the Falco logs. And then once we know which namespace and the pod name is in question, we have to enter those values into this particular file location. Let's go about checking the Falco logs. The way to do that is, and in Falco logs, what exactly to search for? Let's search for maybe grep into something like package, because the question is talking about packages getting updated. So the command for this use case would look like grep minus case insensitive package in the location where our logs are getting generated. There you have the result. And if you closely look at the event, it says user is root, container ID, container name, K8's Eden software to Eden Prime. So from this container name, we can make out that this application, which is having these package related error events, is in the Eden namespace, not Citadel or the third one. We need to go into the Eden namespace and find out the deployment name, the pod name, which is creating this container. So let's head over to the Eden namespace. Maybe let's use the config set context command to land into the particular namespace. Now let's do kubectl get pod. It says no resource is found in Eden namespace. Actually, looking back at the question, the namespace is Eden Prime, not Eden. So let's redo our previous command. There are quite a few pods. We will need to describe these pods and see which one actually has a container creating named software 2. So from the name, it looks like probably it's Eden software 2. We can get more details about this pod just to be sure. In the containers, there you go. The name of the container is Eden software 2. So the name of the pod that we are after is Eden software 2. So we have the information we wanted. We just need to save the namespace and the pod name in this particular file. Let's just do that. Okay, let's hit on the check button. Yes, the security report section is all green now. Now let's head over to the Eden Prime namespace. Let's click on this pod section. It says that delete the pod belonging to the Eden Prime namespace that was flagged in the security report. So we have just identified that. The ask is pretty straightforward. We just need to deploy this pod. We are already in the Eden Prime namespace on this terminal when we were actually searching for this namespace and pod name. What we can do is we can use our delete alias directly without specifying namespace, as we are already in the Eden Prime namespace. Delete pod, and the name of the pod was Eden Software 2. The pod is deleted. Pod is deleted. Now let's move over to Citadel namespace. Before doing any operation on the Citadel namespace, let's switch to the Citadel namespace itself. Deploy. It says delete the role binding causing constant deletion and creation of config map and pods in this namespace. Do not delete any other role binding. So we need to delete the role binding. We had already found the role binding earlier and saved as part of our security report. There you go. So we need to delete this particular role binding as part of the ask of this part of this question. Let's use our delete alias. Delete role binding. Important binding, do not delete. The name is very confusing, but the right solution is to actually delete this role binding, as this is what is creating all the problem. This is done. Now let's look at the second part of this namespace, secret. Delete the role causing the deletion. We have already deleted the role binding. Let's delete the role as well. All good. Let's hit the check button. Heading over to the Omega section. This part is already coming as taken care of, so we need not do anything here. That's about it. That completes our lab. Quick recap of what all we did in this question. We started by creating a audit policy YAML file. We loaded that YAML file into Kube API server and specified the log path location as given in the question. Then we enabled Falco. We installed Falco from scratch. These audit logs became input of that Falco. We enabled file output logging for Falco at the location given to us. And then we had to identify a couple of things from the audit logs as well as the Falco logs. We did that from respective log files that were generated. And based on our findings, we head over to the respective namespaces and fix the issues that were there with the respective resources in these namespaces. That's about it. That completes our lab challenge number 4. So thank you, and we'll connect sometime in future with the next video. Thank you. Bye.